This lesson focuses on different types of graphs and how we can read them. Mostly here we're going to talk about the broken line graphs that we've been drawing. So when we're looking at a graph, there's two ways that we can read it. We can make interpolations, or we can interpolate some data, or we can extrapolate data from the graph. Both of these are ways of getting some information from the graph. Now when we interpolate, we're actually making an educated prediction from data within the graph. So it's actually in the line, it's something we can see. If we're going to extrapolate, that means we're making an educated prediction or an educated guess from data that's not contained in the graph. Basically, we look at the graph, look for a trend, and then go beyond where the graph actually is and saying, well, if the graph continued, I think it would be about here. So we try to use the trend to get us to see what could happen beyond what's provided in the graph. So we'll look at this first example. The following graph shows the growth rate of a bean plant that David planted in his garden. So we can see that the height is going up the side in centimeters. We have the week numbers down here. And right at the beginning, when he planted it at the 0 week, the plant was a little bit taller than 0. So he must have planted it in the ground, already grown. Now it says David forgot to record the height of the bean plant in week 4. Use the graph to interpolate the height of the plant that week. So interpolate, that means the data must be in the graph somewhere. Now it says week 4, so on the bottom is weeks, and we go to week 4. And we just follow the graph up, and we say, well, here it is at about week 4, somewhere right here. That data's in the graph. The plant must have been somewhere there. So if we look, here's 20, here's 30, here's halfway in between, so this must be 25. This is less than 25, but not quite in the middle, so maybe we'd say around 21 or 22 centimeters. So 21 or 22 centimeters. So we interpolated that data from within the graph. Now it says, what might the height of the plant be in week 12? So if we look at the weeks at the bottom, we're only at week 11. So we're going beyond what the graph says. Week 12 is going to be somewhere over here. And if I look up and we examine the trend right here at the end, you can see that the growth of this plant is actually starting to level out. So I'd say the growth somewhere around here. So if I look again, it's just under 40. We could extrapolate data from the graph, and we could say it's going to be approximately, and we're just taking a guess, an educated prediction, approximately about 39 centimeters. It's right under 40. So week 12 wasn't on the graph, so we had to extrapolate our data to see what the information might be. The last statement here says, or the last question, write a statement describing the trends in the bean plant's growth from week 0 to week 11. So I'm just going to get it so we can see both of these on the same page. And we got the graph it's saying make growth rate from 0 to 11. So we could take a look at what's actually happening within our graph. This first part of the graph, you can see there's pretty fast growth all the way to about here. So if we were going to say some describing trends, we're saying like from 0 to 5 weeks, what are we noticing? This bean plant grew the fastest. So here's the trend. It's growing really fast in those weeks. Now beyond 5, if we look, so from about 5 weeks all the way to here, the plant's still growing. It's still doing something, but it's not growing as fast. So we could say, well, between weeks 5 and 9, what do we notice? The plant's growing, but it's growing slower. So the trend is it's starting to grow slower than it has when it first started out, when it was between 0 and 5 weeks. Now we examine the last sort of bit of this graph, which was right here. We've already looked at this. Between weeks 9 and 11, we could say that, you know what, the plant has almost shown no growth. So that's another trend. Between weeks 9 and 11, there's almost no growth of this bean plant. And we just looked at the graph, looked at some trends where we saw the first section was growing really fast, then there was still growth but not as fast, and then it leveled off. So we talk about just how the graph looks. So now we're going to go to the next example, and we start talking about a real estate agent, and he's listing Vancouver prices, comparing from Vancouver to Regina. So we're going to have to come up with a way to graph these in a broken line graph, it asks. Now, I put some information on here, and I said, okay, on the bottom, these will be my years. In the 2000s, I went up, I started at 6, went to 7 every 3 spaces, 2006. And then the house prices, I examined in the chart, the lowest price is in the 100,000s, the highest price is just under 700,000. So every 2 spaces, I put another 100,000. Now, the title on the graph that I chose, it says Regina house prices. That's not quite accurate. This is Regina house prices compared to Vancouver house prices. So it has to represent the data in the chart. So what you should start doing is look at Regina. We're going to have a double broken line graph, and we should maybe come up with some different colors. So I'm going to say lines that are in red, this is going to be Regina. Then I'll just choose another color. Maybe I'll just use black. Lines that are in black, this will be Vancouver. So we have to go through and now plot the years and the prices. And you're going to see there's going to be some estimation here because, like Regina, in 2006, the house price was 132,000. So I go to 2006, and I could see between 100 and 200,000, that'd be 150. So I'm going to estimate that 132,000 somewhere in there. Then I go to 2007. I'm at 167,000. So I would now go up above 150 and say I'm somewhere in this ballpark. 2008 is 230,000. So I'd be just underneath 250. And we keep plotting these points as we go across. 2009, we're steady at 230,000. So 2009, we would show no increase in the house price. And then 2010, 232,000, slightly higher, not too much, so a little bit there. And now we could connect these points saying here's the graph, it goes up, it flattened out, and then it kind of went across. So now pause the video and put on the points for Vancouver and connect the dots. So pause your video and plot Vancouver's points. So now after you plotted your points, you should see, and in my case I used black, you should see Vancouver's average house prices from the years 2006 to 2010. Now we got to make some info or talk about some information from this graph. What conclusions can you draw from the table about house prices in the two cities? Well, the first off, if we were looking at the table and looking at Regina's house prices in Vancouver, the most glaring thing we can say is that Regina's house prices are way cheaper than Vancouver. So Regina houses cheaper than Vancouver's house prices, for sure. The other thing we should be able to tell from the table, they started low and they did increase over time. So we could say the prices in each city increased. So there were some years where in Vancouver that it actually went down from 2007 to 2008, went from 594,000 to 592, but the overall trend of the graph is up. Now it says, what can you tell from the graph more readily than the table? So what makes it easier looking at the graph than the table? The biggest difference you can see is that Vancouver prices are a lot higher. So in the table, we know it's higher. We can see the numbers. But when you see it actually in the graph, all of this shows how much more expensive Vancouver is than Regina. It's a lot more. And the other thing that you can see is the price trend is easier to visualize. So we can see that it's going up, and we can see where it actually leveled out. There was no growth, little dips in it. So just looking at the broken line graph, we could maybe tell a little bit more information. The biggest one we could see from the graph is just how much more expensive comparable houses are in Vancouver than they are in Regina. So graphs are just a way to take something that's just from a table, a whole bunch of numbers, as in this case. We could still make some information or make some predictions based on these charts here, but when we remove the numbers and put it on a table, it's just a lot easier to visualize what's actually happening or how things compare in different situations. So we're going to move on to now something that's used a lot in advertisement, and it's called a misleading graph. Now, a misleading graph doesn't mean that they're graphing incorrectly. They're just choosing their scales on the x-axis or the y-axis. They're choosing their scales to suit their needs. So we can see a misleading graph, it says, is used to show a certain point of view. So advertisements use it a lot. And another way to talk about it, misleading graphs often exaggerate data. They make things look better than they are, or they make things look worse than they are. So if you're advertising, you try to make your competitor look worse by showing a very misleading graph. So we're going to examine the cost of sheet metal here by year in two different graphs, and we're going to look and see exactly how they differ. So in this first guide, that's example 5, it's saying the graph below indicates the approximate cost of sheet metal per ton over a period of time. And we could see it. The cost per ton up the side, and the months going from January 2005 to 2009. And says, what does it appear has happened to the price of sheet metal over time? If you just look at it, it's like going up, down, it's just going all this. What is that actually telling you? Well, it's telling you that the price fluctuated. Like it's all over the place. And you could see from the first time they took it in January of 2005, it looks like the price just went down. And then within 1 year, the price just shot back up and then dropped right back down. This is what your eyes see in this graph. But if you compare the scale, you could see this part here means, you know what, we've taken a whole chunk out of this graph. We jumped from 0 to 500, so we could make these spaces look a lot bigger and show that the price of sheet metal is actually changing a lot over time. What are the scale and the starting points of the vertical axis? Well, this is the vertical axis going up. This is where vertical goes. We could say, well, it starts at $500. And the scale they use, if we look, so it's at 500, then it's 550 with something in the middle. The scale then, whoops, scale, I'll just restart that. Whoa. Is $25. It's jumping up $25 each time, and you can see 500 to 525 to 550 to 575 to 6. So our scale is at $25. Now we're going to compare this, the exact same information on another graph, which is right here. So this graph has been redrawn, and we started now at 0 for our prices. And instead of going up by 25, we're going up by 75 each time. And this is the exact same information. And it's saying, what does, now that we changed our scale on this vertical axis starting at 0, what does this new graph show about these fluctuations in prices? What does it actually show us? Well, it's telling us the fluctuations were not as drastic. That, yeah, the price is still going up and down, but now when I show all the numbers here and make the graph a little bit more comparable to money, we can see, yeah, the price went down, it went up, it went down, but it doesn't seem as drastic because I actually pulled away from the graph, didn't zoom into all those fluctuations. The fluctuations don't look as drastic here as they do on the exact same graph with a different scale chosen on the vertical axis. So this first one makes it look like the price is bouncing all over the place. This guy, same information, same graph. It's just now that the fluctuations don't look as big. So you can see that companies, especially in advertising, can use misleading graphs to sell their product or to make their competitor look worse.